guys, Mr. Mayes is here, and this time I'm going over rates of change. In calculus, we really have two types of rates of change that we're looking at. Now, rates of change means it's the rate at which something changes either over time or over some other variable. We have two types. We have the average rate of change. That's how something changes, or its slope, from one place to the next place, okay? So in this case, the average rate of change is the slope, delta y over delta x. Here's another way to write it, f of b minus f of a over b minus a. The instantaneous rate of change is the rate of change at a particular moment in time, or at a certain value. So you think about this. If I'm driving down the highway, and I go from 0 to 10 miles, I do have an average velocity, or average speed that I do, right? But at exactly 10 minutes or 10 miles, at exactly a point in time that I'm traveling, I'm still traveling, right? And I still have some sort of speed going on. It's not like it doesn't stop altogether. I do have a certain speed. That's called the instantaneous rate of change at a certain time. That turns out to be the slope of the tangent line, which is the derivative at that point, okay? So we can find these rates of changes. So here's my first example. F of x equals x cubed plus 2x. Let's find the average rate of change from x equals 10 to x equals 30. So the average rate of change is going to be, I'm going to plug in, so it's going to be f of 30 minus f of 10 over 30 minus 10. It's really important that you go, it starts from where you're going to kind of end. So it goes b minus a, so 30 minus 10, all right? So I'm going to go and plug these values in, and I'm going to get 30 cubed plus 2 times 30, that's that first part, minus f of 10, which is going to be 10 cubed minus 2 times 10, all over 30 minus 10. And that's good enough for us, all right? Now the instantaneous rate of change is when it's at a certain time. Okay, if some of you are going, oh, I can't handle seeing that way, that's a perfectly okay answer. We're not going to use it again. If we were going to use the actual value again in another problem, then we'd want to find out what that actual value is altogether. But, you know, I think I did that in the calculator correctly. I got 1302. But we can leave it like that. All right, so this last one here, we're finding the instantaneous rate of change, so I'm going to take the derivative. Whenever you see the word instantaneous, that means take the derivative. Instantaneous, take the derivative. Okay, and then we're going to plug in 10. So f prime of 10 is going to be 3 times 10 squared plus 2. And again, that's good enough for us. We can go ahead and leave it like that if you really, really wanted to, because it's angering you. I do believe that's 302. All right? So that is rates of change. All right? See ya.